we're going to be learning about differentials and differential gear ratios. And behind me I've got a Dana 35 and an 03 Wrangler. Stock gear ratio on this is a 373 ratio. And we're going to be swapping them out and making this a 456 gear ratio. So we'll go over what that means, why we might do that, and I'll try and break this up into a couple segments so you can follow along. Let's go take a look at some differential parts. All right, first thing I want to do is go over the parts in a differential or a rear end, or in this case we're actually looking at the front differential, so you could call it a front end. But all the way in the back of the case right here, we have the pinion gear, which is spun directly by the front drive shaft, or if we're talking about the rear differential, it'd be the rear drive shaft. So as the pinion gear turns, it spins the ring gear. The ring gear is bolted to the differential. The differential has side gears and differential pinions, more commonly referred to as spider gears. The differential allows our front wheels to spin at different speeds required when we're going around a turn. So whenever you make a turn, your outside wheel has to travel faster than your inside wheel in order to arrive at the end of the turn at the same time. So again, we've got a pinion gear all the way back here. The pinion is going to drive the ring gear. The ring gear is bolted to the differential carrier, and the carrier houses side gears and differential pinions or spider gears. And now we're going to look at what gear ratios mean, why we're going from 410 to 456 on this, and what does that mean, 410 and 456. So we'll take a look at what came out of this and what's going into that to get a better understanding. We're looking at the pinion and ring gear that came out of the Dana 30 front differential, and we're looking at the pinion and the ring gear that came, or is going into, excuse me, the Dana 35 rear differential. So there are some size differences in the length of the pinion. However, the gear ratios front and rear have to be the same. So we'll calculate what the old gear ratio was, and that's just number of pinion teeth and number of ring gear teeth. So if I divide the number of ring gear teeth by the number of pinion teeth, that tells me how many times I have to turn my pinion gear to get one revolution of the ring gear or one revolution of the axle. So in my best chipmunk voice, I will count my pinion teeth.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
We've got 11 pinion teeth. Now, I'll count my ring gear teeth in my best chipmunk voice.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. So, when we divide 41 by 11, we are going to get our gear ratio that came out of this Jeep. So we'll do that math now and check and see what our gear ratio is. We're looking at our original gearing here. So we have 11 pinion teeth, 41 ring gear teeth, and when we divide 41 by 11, we get 3.7272 repeating. Our gear ratio is only going to go down to the hundredths, so we're going to round up from 7.2, and this gear ratio is going to become 373 was our stock ratio. All right, so our new ring gear and pinion gear
and we're going to calculate our new gear ratio. First, we're going to count our pinion teeth.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Now our ring gear teeth.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41 ring gear teeth.
So again, we divide ring gear by pinion teeth, and we have our new gear ratio. So we'll do that math now and take a look at what we're moving up to. Now we'll take a look at what we're changing to. We had 9 pinion teeth, 41 ring gear teeth, and when we divide 41 by 9, we get 4.5 repeating. Again, we're only going to the hundredths place, so we're going to round that 5 up, and our new ratio becomes 456. So stock, we were 373, and we're gonna step up to 456. And why would we do something like that? Well, let's take a look at the Jeep for the answer to that question. If you come over and take a look at these tires, these are 35 by 12 inch tires. That is not what this Jeep came with stock. This is a much larger tire. So for the same RPM, if we spin these larger tires, we're going to be going faster than what our speedometer says. The problem with these stock gears are the transmission has been matched to the rear and the tires, and fourth gear, this engine just doesn't have the torque, the power to turn fourth gear in this automatic transmission and get overdrive to happen and torque converter to lock up and happen. It's struggling with that 373 ratio. So we're jumping all the way up to 456. Stay tuned. We'll go over setup on this differential and rear end, and we'll also talk about posi or limited slip traction and how can I tell if my posi or limited slip differential's doing anything.